Hello, everyone. Good morning. Let me share my screen and let's start with our session today. Okay, today is day two of our wonderful Docker and Kubernetes course, and I'm excited to share you guys. One second, let me share the whole screen then. Okay. Okay, fantastic. Anybody who didn't attend yesterday's session, can you please let me know in the chat? Someone joined only today and they missed yesterday's session. Is there someone who missed yesterday? Can you guys, and also, can you please let me know in the chat whether you are able to see the screen being shared and hear my voice clearly? If you hear it clearly and see my screen, can you put S and yes two times so that it will help me understand that I'm in the right direction. I can see Anil, Bharat, Divya, Kushal, Machindra, Param, Rishabh, Sandeep, Sudhakar, Sudhir, and Tausif. Hello, guys. Good morning, good evening, everyone. So, can someone put it in the chat, please? Okay, thank you, Tausif, Param, and Anil, for helping me out. Cool, cool. If anybody is absolutely new and didn't attend yesterday's session, please let me know. And we will start with our day two of our Docker and Kubernetes session. So, for the sake of someone who is new, so just quickly in 2 minutes, what happened yesterday is that we have learned that, why do we need kube why do we need to learn Docker and Kubernetes first of all? Okay, because without a premise, without a reason, we don't need to learn or do any activity, right? So we learned that, there is a lot of demand out there for Docker and Kubernetes, because Docker and Kubernetes for automation tools are software which help us in shipping our code and applications faster to the clients. Okay, and the job market favors those who learn automation skills. So I have shown you, like, even Java architects, software testing engineers. If you go to Naukri or LinkedIn, you search for JD's job descriptions, you will see these two tools mandatorily list. Okay, so you must learn whoever you are in the IT field. And if you want to survive after certain years of experience, right, you get stagnated sometimes. So in order to avoid being seen as someone who didn't upskill, you need to upskill in certain niche areas like Docker and Kubernetes, so that you can lead your teams towards progress and delivering the software faster. So these are certain reasons we discussed yesterday, and you have, like, there are certain challenges how to learn them, and how we are here helping you to handhold you and guide you towards learning it step by step in a gradual manner where you can master these skills. Okay, so that's all about yesterday. So we will dive into today's session, where what was the situation earlier. Okay, how it used to be pre-Docker era, pre-container era, what used to happen, and today, and what are the challenges during those days, and what led to containerization. Then we will go little deep into what a container is, and how containerization will help, and other areas of it. So if you're already an experienced engineer with knowledge about Docker and Kubernetes, please consider this as a refresher, and I'll be, giving you certain insights into how I faced my experiences was with containers, and also it would be a fun discussion. So for freshers, it would be a very informative session. So don't skip till the end, and I have a surprise for all of you guys if you stick till the end. Okay, so let's go ahead and let's start with our history class. So long ago, what used to happen before Docker, you know, when we want to ship containers, let me open a paint screen that would be helpful for teaching. Okay. So long ago, that is around 2010, around that, and before that, what used to happen whenever there is a software to be built and software to be shipped means to be sent to the end user or the client. Okay, so learn this jargon and use it when you are in your environment. So when you build a software and ship the software to your client or the end user, how it used to be like developers build their code and they used to ship it or send it to a server. Okay, this server used to be huge rack servers, If you have seen some pictures of Google data centers, that's how the companies used to host their data centers. Still, some companies use on-premises data centers for their deeply sensitive stuff and all. So they used to share the code, and that used to be deployed by someone called ops team. Okay, operations team or ops team. Okay, ops teams used to take that code and deploy into the server and meticulously used to install all the requirements. Now the question is, what kind of requirements, Vijay, you might ask? Okay, for any software to run, you need certain libraries, certain dependencies, certain drivers required. Okay, these kind of things are dependencies. Who tells operations team which libraries and which dependencies are required? Development team has to inform the operations team what kind of libraries their software or our software is going to use. So this ops team, what is their job? They used to set up these servers and also bring the code and install that code or run this application on this server. And most of the times it used to fail. Okay, the reason was that because there was a version mismatches that used to happen. Okay, so then there was a blame game that used to start, that developers used to say, but it works on my machine, why is it not working on your server? Operations team used to say, no, our servers are fantastic, your code is buggy. So there used to be blame game. This we discussed already yesterday, right? Then what evolved from here is, let's find out a solution. Let's create something called a virtual machine. What is a virtual machine? A computer or a server inside a bigger server. Virtual computer, virtual server. Okay, what is this virtual machine did? They were a isolated environment with software, operating system, and everything bundled together, but they are heavyweight. Why do I call it heavyweight? When you go to, how many of you remember that when we start our Windows a few years back, it used to take almost like 30 seconds to 1 minute to boot up, right? Even Linux used to take some time to boot up, right? Like few seconds. So that delay, why is it required? Because whenever an operating system boots up, right, there is something called bootloader and some boot process used to start. That is like kicking in, all the necessary dependencies and all, and it used to start. But this boot time is caused by operating system. When you include operating system, that itself makes it heavyweight and very less agile. Like it's like a big mammoth or elephant. You cannot move an elephant very easily. So that's why people. Although the virtual machine slightly addresses the problem, but it is not flexible enough that you quickly deploy it and quickly identify the changes and do troubleshooting and all. So it's not quicker, it's not agile. So what people thought is, like, okay, let's move from something this rigid to flexible model. Okay, so for that what they did was to bring something lightweight, which doesn't have operating system, but like a parasite, which will use the resources of a host system. Why can't we mimic the nature and create something very lightweight, which will utilize the underlying operating system itself? Okay, you understood? How does a bacteria or virus do? It survives on the host's body, right? Similarly, if the example is bad, please forgive me. Okay, pardon my language. But basically, we want to mimic the nature. Nature is always, paramount. It's the biggest invention that ever happened. Okay, so why can't we learn from few lessons from it? So what these genius engineers thought was, since virtual machines are heavyweight, let's create some lightweight micro virtual machines without operating system, but let's package the code and let's package the dependencies. I said dependencies. What are the dependencies? Libraries and certain drivers required. These libraries and certain settings are the drivers and the actual code of the application. Why can't we package it and make it so flexible that wherever we deploy it, whether it is on developer's machine or whether it is an operations team servers or whether it is an client's environment, wherever we deploy, it should exactly work the same. Wow, that's a superb concept, right? We already had this concept, right? Where did you see it? For example, do you remember seeing a container? Huh, guys? Do you see containers? If you see the containers, each container has certain dimensions to it. Each container is with a fixed dimension. When you want to ship your cargo from your warehouse or a factory to a let's say to a port, okay, how do you transport the container? You put it on a truck or you put it on a train and you send it to the port. And on the port, what they do, they load it onto a ship, and that will be that will carry the container to the destination. So and then it will be unloaded and the process will be continuing. Now, in all this journey from starting point A to point B, the container is not getting affected. You understood what I'm saying? The containers are not getting disturbed, but we are able to safely transfer the container from your place to the destination, although the vehicle is different, whether it is a truck, train, or a ship, or even sometimes the flight. Okay, the containers, the way you use it, are same. So containers comes from that inspiration of container. Okay, the shipping container. That's the idea actually. That how a physical container which transport the cargo, we need to mimic that example, and we need to build something which will carry on the code and dependencies with reusability. Understand? So we want, what is a container? So when an interviewer asks you what is a container, basically your answer is going to be a container is a file. Basically it packages code, the software code and all the dependencies into a single unit. So you can give a professional answer, and also for your understanding, it's just a package. Okay, now what is an image and what is a container? That's the second question. So what used to happen? Now, imagine you are a software architect. Oh, sorry, you are a civil engineer or a architect. You build, villas, or you build apartments. What do you do first? You draw a blueprint. Am I right? Nobody starts directly. You see a land, dig it, construct it. No, first you plan it, right? You plan using a something called a blueprint. Let's say you want to construct 100 villas. Okay, how does an architect think? How does a civil engineer does? He or she will take up a blueprint and thinks that, okay, I will take one. If there is one villa, how it is going to be? If it is west facing east, facing west, facing north, facing south, they will create certain blueprints for it. Like for example, there will be room, there will be bathroom, there will be entrance, hallway, etc., etc. Okay. Now this design will be conveyed to the builder. The builder's responsibility is to take this logical blueprint and construct a real villa or a house based on this blueprint. Now, the blueprint has everything necessary to construct a what do you call, like a villa or a building, but this is logical. Okay, but in runtime, that means in reality, they refer to this blueprint and they construct the real building, right? Now you understand what is a template, what is a real thing. Okay. Similarly, you can build 100 houses if you have the necessary resources like cement, concrete, and necessary human resources, and then you have the blueprint to it. So if you have the blueprint, if you have the resources and the capital, you can build n number of houses without any difficulty. Am I right? Similarly, the idea of containers needs certain blueprint. Okay, so Docker is not only just a containerization tool. The Docker is a very sophisticated software or a tool which will let you command it to build something like a template. We call it Docker file. Okay, we will learn step by step in future sessions how to build a Docker file. Okay, so you can build a Docker file. Docker file is like a set of instructions. Like for example, how do you give prompt to a chat GPT? You tell it, hey chat GPT, I need this. Give me the rest of the content. Something like that. Like that. So Docker file is just a set of instructions telling the Docker software itself that I need a particular template using which I can create containers. Okay. This is just a set of instructions. Set of instructions. Now, this Docker file, which is a set of instructions, will be used by Docker to create a template. What did I say? Template is the most important thing without which you cannot build a container. So it will create a template. The template again will have exactly how a container look like. Template, sorry. Template. This template will have everything like the software code, the necessary code for application, the necessary dependencies like libraries, certain drivers and some other necessary things, and it will create this packaged template. We call this template in Docker jargon as image. Okay, 1 second, guys. Image. Okay, what is an image or a Docker image? A Docker image is a template. Basically, it is a static version of your container. Okay, so let's not, when somebody asks you, an interviewer asks you what's a Docker image. Docker image is a template basically consisting of the software code and the necessary dependencies packaged into a static thing. Now, like a civil engineer, how he builds a real house from the blueprint, when you want to run a container, you tell the Docker again, hey Docker, I have this template. Now spin up containers from this. Now the Docker beautifully builds n number of containers from this image. So what is a container? Now the relation between container and an image. Container is a runtime replica of an image. What is runtime? Runtime means during the, okay. Runtime means during the time of execution. There are several meanings to runtime based on the context. For here, understand runtime as the time during which, for this course, when I say runtime, it means that during the execution. Okay, there is another meaning to runtime. That means the way or the software used to execute certain code also is called runtime. Let's not go into there. But during the execution phase or during the runtime, a runtime copy of your image is called a container. This is the core difference. So if somebody asks you what is a Docker container and how is it different from Docker image? So Docker image is a static package template, a static package file comprising of your your code, package dependencies together. And container is a replica or a runtime copy of your image. Image doesn't run directly. Understand, any container runtime environment. What is CRE? Container runtime environment. That is Docker. Docker is called container runtime environment. Like that, many other tools are there. Of course, competitors always exist, right? So it comes, Docker comes. Yesterday we learned that it is a containerization tool. We also call it as container runtime environment. So any CRE or container runtime environment needs image to build a container. Understand? Okay, so let's go and learn. Till here, any doubts? I want to be interactive with you guys. If you have doubts, put it in the chat, or you can raise your hand and I'll take your queries after certain point of time. Okay, so that I won't disturb, like, the flow of the class. If you have any queries, put it in the chat, or you can raise your hand and keep it up so that I can take your queries maybe at the end of the session or after certain time. Now, coming back to our discussion, like where were we? Yeah, this I have discussed, like, there were certain problems before Docker. One is the environment where the code is built was different from the environment where it was run. Because of the differences in the environment, there used to be blame game and issues. Similarly, from employee to employee, the development environment used to vary because the desktops used to vary. And the tools and libraries required for different projects used to vary. These were certain problems before Docker. Okay. So what was the really solution? So we don't want to depend on anything. Okay, we want to build and test in the exactly same environment where it is built. Similarly, we want every team member to build their code and test it in an identical environment. Similarly, if it is different teams within a project or different project, they can use the similar tools and similar environment. So containers achieve this, help us in achieving these goals. Okay. So now let's briefly, go through our history. Is containers really new, or containers are something old? Okay, many people think that the idea of containers is very recent, like maybe 10 years old or 12 years old, and they think that, like, it's an innovation. But although the word containers might be new, but the idea to isolate and run processes is not new. The idea was there since 1970s. When the Unix was brought, there was a process isolation built into it in Unix version 7. Similarly, in 2000s, pre-BSD, there were clear separation between services, and then Linux brought in certain partition system resources, and so on to that. But the maturity or the level of containerization really actually helped people when Docker was launched in 2013. Okay, so when in 2013, when Docker was launched, basically it made use of all the Linux-based services only, but it added a layer of abstraction and increased the sophistication of the way we isolate the process and all. So, and then in 2017 and all, the containerization matured, and orchestration got introduced through Kubernetes. By the way, many of you, if you don't know, I'll be discussing during the introduction of Kubernetes. Kubernetes is a brainchild of Google. Google built it for their own Google problems, like managing huge whales called Gmail, Photos, Google Photos, and there were so many things, right? Google wanted to address their application, so they built their own system called Borg, and I don't know, like many rich people turn into philanthropists, giving away their wealth. Google also felt very philanthropic way, and they thought, like, of course there is a slight selfishness to it, but anyways, let's not go into that. So Google donated it or make it available to all the community out there. We call it making it open source. And Kubernetes Foundation, we call it CNCF. Okay, that CNCF ecosystem, they took the responsibility in making Kubernetes popular. So that's the history that went into this. So for those history buffs out there, this is how it evolved. And then that's what. In Linux, there used to be C groups and namespaces. The idea of namespaces and all came from Linux and all. And yes, you go through this PPT. I will be sharing with you all the PPTs and all, and you can go through this uh, at any point of time. But what are the core benefits? Okay, if you want to, like, understand. Sorry for certain things. Certain pictures are not reliably replicated here, but anyways, okay. So what is the advantages we are getting based on this Docker and containerization? What is the clear advantage? For example, when somebody asks you, hey Divya, or hey Tausif, why do you need a Docker and containerization? The pretty straightforward answer is that Docker gives you several advantages over the traditional model of shipping software. What are those advantages? Docker, or the containers, are very lightweight. By lightweight, they are very quick to start and scale up or down and automatically meet the demand. How many of you have you seen Hotstar or any ESPN or Crick Info? This kind of sports related event. Have you followed? Have you seen that just before the match starts? Okay, there will be like few thousands of users during the live stream, right? But when the match starts, it will increase to 1 million or so. But when it really matters, the fag end of the overs or the climax, okay, there will be millions of users, right? It won't be gradual. No, suddenly people will flock into seeing that, wow, this match has turned into interesting match. Okay, how do you think in the background The systems are so scalable that it can accommodate millions of users without buffering. You won't even, if you have a good bandwidth, internet bandwidth, you won't feel the buffering at all. But the backend system, it supports so huge. How is that miracle is made possible due to containerization? In the backend, all of them use something called Kubernetes. Okay, so the containers made it possible to scale millions and trillions of required, tools and applications, sorry, processes, so that everything works seamlessly to give user a single interface of application. Okay, so containers are lightweight without operating system. It is very lightweight. So like a kite, right? How does a kite fly? It fly like, rapidly with the wind. It flows with the wind. It's so agile, so quick, right? So it can start and scale up or down automatically to meet the demand. The first advantage. So next, is it enough to have scalability? What if it fails? What if it crashes? We need something called consistency, or I know efficiency. So consistency means when you build it at one place, let's say for example, who are there? Let's say Abhilash has built in his system one the software, but Amit want to test it in his system. Let's say Anil want to test deploy it into production. Okay, so what happens is that whenever someone builds it, it has to be consistently run anywhere. Okay, identical environments should be there so that your application doesn't need to modify itself according to that. Understand? So containers are portable. That means you can run on any infrastructure. If you have a small, small VM, you want to deploy a container into it, you can do it. If you have a huge, containers, Kubernetes clusters with several hundreds of nodes, you can run it. Portability and consistency are hallmarks of Docker containers. Okay, and security. Once you build a container, you can make it foolproof that nobody can meddle with it. So that's how you can make it more secure. Okay, in future sessions we will be learning how to make a container secure, how to make a container foolproof, how to make a container consistent, portable, and also agile. Okay, of course you can build it through pipeline, you can deploy it through pipeline. That we call it in DevOps terms CI/CD. Okay, continuous integration and continuous deployment. Okay, so these are the benefits. Okay, if somebody asks you, "Hey Harsha, tell me why do we need Docker?" Or if somebody asks you, "Hey Kosivi, how do I do that?" So you just need to understand, but don't remember them rot. Rot learning is not what I'm driving. But first understand this, and then in future classes, I will link the topic or the idea to this, so that then you clearly understand how Docker achieves this scalability, how containers achieve this consistency. These might be a literal ideas to you, but when I teach you and you work hands-on on the labs I'm going to give you, you understand how they really manifest into these benefits. Okay, so for now, understand that this is a theoretical explanation, but in true, we will be learning all these things through building containers with our hands. Okay, so if somebody asks you, Tausif, we have virtual machines. Why do we need containers? Then you can clearly tell them that virtual machines are like elephant. They need an operating system per application. You need hardware level virtualization. It needs certain resources which are an overhead for running the VM itself, and startup time is very high. And if you want to achieve, compatibility with legacy workloads, it is difficult. But whereas containers, virtualization doesn't happen just at resource level, infra level, but at operating system level, virtualization happens. If somebody doesn't understand virtualization at OS level and virtualization at hardware level, tomorrow I'll be going little deeper also. So just hold on for then. Okay, it is lightweight because we are not packaging operating system. Only code is there, so it is lightweight. And since it is lightweight, it it needs lesser resources, and it needs less time to boot up also. Okay, ideal for microservices. Nowadays, understand, very few companies are continuing their legacy monolithic code. And many of the organizations, they are moving towards digital refactoring of code from monolithic to microservices based architecture. If it is a greenfield project, that means a freshly new one, nobody even thinks about monolithic. Always they go for microservices. So when I talk about microservices, you need to have containerization, you need to have orchestration. Okay, so that how things goes on. So what kind of challenges um, does containers, is containerization so beautiful, then why do you need orchestration? If somebody asks you a question, right, when you go to interview, definitely your question will rise. If Docker is so beautiful, Docker containers are so agile, no flaws, then why do you need Kubernetes? So Docker containers are so lightweight, and when applications are run with container, literally it is difficult for a human being to monitor them and manage their complexity levels through human mind. You cannot literally pick one container, restart it. What if 100 containers need to be, you need to restart them? Maybe version change happened, something didn't turn up well, you need to roll back. So how do you do that? It is difficult, right? That is one challenge. Then how do you place them as per the resources available? Let's say at the underlying core, everything is run on a virtual machine, VMs. Okay. Basically, in AWS, you have EC2 instances, right? In Azure, we have Azure VM. In GCP, we have GCP virtual machine. So basically, GCP computer, basically. So at the core, you have virtual machines, and you will be using that resources to run containers. But dynamically allocating containers manually is not possible. It's not feasible, it's not worth your time in allocating. Okay, let's say 10 containers I'm deploying into VM1, 20 containers I'm deploying into VM2. No, that's not going to happen. That's not that dynamic placement is not humanly possible. And finally, manual update, scaling, recovery, these things, when you hand over tackle them manually, maybe at the testing phase, one or two containers is okay, but when you scale up, when it becomes hundreds of containers, it's very difficult. So these are the challenges. What is the solution? Orchestration is the solution. Orchestration is the way or the philosophy how to manage your containers and the complexity around containers in a seamless manner by abstracting everything. So as a user, as a administrator, as a DevOps platform engineer, I don't need to bother about how a container's life cycle is going on, whether I need to restart it or not, whether updates are going for each of it or not. No, I don't need to bother. I need just an orchestration tool which can take care of the scaling, scheduling, and automates the deployment and other things. It should take care of networking so that whenever there are containers of the same type deployed in multiple VMs, they should be able to talk to each other. uh, my orchestrator should give some load balancing services also, so that whenever some request comes, it should be routed properly to different containers of the same type. And also it should provide high availability and self-healing for my microservices. And who provides all these services? An orchestrator or orchestration engine provides. And what is our best and industry leader in orchestration? Kubernetes. Understand? We use Kubernetes to solve the problem that are inherent with managing containers manually. Containers by themselves are very good, agile, but when there are huge number of containers, human limitations are there. So to overcome those limitations, we need another tool to orchestrate everything or manage everything. So Kubernetes helps in solving the challenges which are posed while managing the containers and associated with the containers. So basically, so we are here at the end of the introduction to containers and Docker. So let me go ahead and see what else we can discuss today. So this I have discussed. So I have discussed. So I have already discussed that, like, when there is a container, you can move it you can make it work on desktop. In a production cluster, you can upload it to cloud registry and run it on cloud VMs. You can run it on data centers and anywhere. Okay, which allows which has a container runtime environment and allows containers to be run. Okay, so basically, there was used to be mainframe servers in 90s, then virtual machines evolved in 2000s and all, VMware and all. Then data center to cloud model evolved, and we are hosting containers, including serverless models today. Okay. So till here, any doubts, anyone? You can raise your hand. You can go to your thing and you can raise your hand, and can unmute you and ask your query. Any doubts? Let me know. I'll grab some water. Okay, let me see who has raised their hand. 1 second. Yeah. Yes, Vaibhav, you can unmute and now you can ask your query.
Yeah, hi Vijay. I want to
Hey.
know which type of lab environment we are using for Kubernetes.
For Kubernetes, we'll be using EKS, AWS EKS, but we will be
All,
discussing
all this, what are the listed in our syllabus with all the topics with practice we have covered, right?
Yeah, there is one module I have already shown you yesterday, but I can show you again. One week we will be discussing different models of Kubernetes. One for testing Minikube we will discuss. For bare metal and classical Kubernetes we will discuss. Like for example, you need to set up the entire cluster on a VM. How to set up it in a data center I will discuss, and then we will discuss about all the major cloud operators. Like we will discuss about AWS EKS, Azure AKS, and GKE. Then for entire rest of the discussion, we will choose one platform, that is AWS
Oh,
EKS.
okay, okay. That's it. Thank you.
Sure, sure. You can lower your hand and mute yourself, please. Anyone else? Anyone has doubt? Please let me know. How is the class going? Did you like the pace? Do you need me to slow down, or you want me to speed up? Okay, we have Machindra here. Hey Machindra, hi. How are you doing today? You can unmute and ask your query.
Hey, hi Vijay.
Hi.
Are we doing some hands-on with you once you taught
Yes.
the topics?
Yes. We will be doing every day. In a day, how much time we have? 60 minutes. Out of that, queries and all will take 10 minutes. So within 15 minutes, I will discuss theory. I will do one practical. So but don't replicate it parallelly. You will miss the concept. First, listen to it carefully. I will share you the exact lab document, how I have implemented these things. What your responsibility? Take that lab document, and I will be giving you how to set up your environment and all. That will take almost like 3 to 4 classes. Once you set up this thing, you will do hands-on everything at your own. And remember, guys, only you have to work to understand. I can teach, you can learn, but you will forget. You need to learn by using the lab documents, which is a step-by-step instructions, and you can implement it. If you get any errors or if you face any problems, next day you ask me in the starting of the session or end of the session. You can share your screen if you want to clear your doubts and everything. I can help you with that, Machindra.
Okay, okay, Vijay.
Sure. Anyone else? Anybody? It's a couple of hands rising up. Okay. So how the rest of the course going to be? You will be having course portal like this. You will have this is an instructor portal, so don't worry. In left side you will have your what is this your course content, day one concept, day two concept, like this. Only if you register you will have access to this thing. And as I promised, there is a surprise for you guys. Now I want you to do a homework, and this is also surprise. So by end of the day, you will be having one document in this portal, LMS portal. Who will get access to that portal? Only if you register, you will get access to that portal. So I'm going to share you one document wherein, without any knowledge of Docker, but if you want to test it, if you are, see, for setting up an environment, it will take 2 days, right? So till then, if you want to taste the Docker, how Docker containers work. If you want to run some quick commands, if you are so eager and if you want to implement, there is something called a sandbox environment, Docker sandbox environment. So I'm going to upload a document which will give you entire detailed information about that, how to set up, how to just quickly within a minute you can run these Docker commands and see for yourself how a container would be, how a image would be like that. So for that surprise gift, you need to register, and you will see that under day two contents. In the day one, the video is uploaded, and I will upload the PPT also. In the day two contents, you will find video, PPT, which I have shared today, and finally the lab document. That is lab one. The first lab I'm going to share with you is the Docker sandbox environment, how you can run it. Okay, for that, please go ahead. If you like the pace, if you like the way I'm sharing, if you like to be not just learn Docker but to master it, master the skills like Docker and Kubernetes, please get the full benefit of the course by registering. How do you register? I'm going to paste here the link for registering. So go ahead and register for the course. And most importantly, you please join the WhatsApp group so that you will get all the intimation about the course. Like, for example, how many of you got intimation that what is the agenda for today? Did anybody got? Let me know. Okay, every day before the one day I will be giving you agenda, like what are we going to learn tomorrow. Okay, like that. So where do you get? Join this WhatsApp group to get the all the information. And this is the payment link, guys. I'll take queries, Kushal, just give me a minute. This is the payment link. Go ahead, guys, complete your payment so that you will get that lab document, and you will play, and you will learn some quick things. Of course, we will be demonstrating it day after tomorrow. Once the demo session's over, we're going to go into full-fledged course. 1 second, is somebody press. Yeah, Kushal, you can unmute and ask your query.
So this Logic Labs, we need to install an application, or this is a web portal which you have
Web
shown?
portal. Web portal. Once you register for the course, my support team will be sharing with you the credentials for your LMS portal, learning management system, we call it. It's just a web portal wherein you
Okay.
can log in and see all the things. It is completely web portal. You will see the recordings, you can play the recordings, you can download the documents and run at your own pace. Okay. Cool. So that's all, guys. Any doubts? Let me know. If not, kindly register for the course to get the full benefits, and to receive my surprise gift. Please register and see at day two contents. After some time, you will see them. Maybe like 1-2 hours. My support team will be logging in at 9 a.m. or so, and they will quickly upload them. And by noon, you can see all the videos and the lab documents which we are going to discuss for quickly testing, quickly running Docker without any installation and other things for testing purpose. Okay. See you guys. See you tomorrow. And thank you everyone for joining this wonderful session. And we will learn the further sessions like what what are the ways to set up a Docker environment and all from tomorrow onwards. Thank you everyone. Thank you Kushal. Thank you Machindra, Vaibhav. Thank you Abhilash, Amit, Anil, Bharat. Thank you Divya, Harsha, Javed, Kosivi, Manasa, Rishabh, Sachin, Sandeep, Sudhir, Tausif, and Yo. Thank you, everyone. And make sure you join the WhatsApp group and pay for the register for the course to get the full benefits of the course. And again, it's my promise not to just teach you Docker and Kubernetes, but make you an experienced professional in Docker and Kubernetes. If you are a fresher, after your course, you can feel like you have 3 to 5 years of experience on Docker and Kubernetes. But there is a condition. Catch is that you need to practice all the labs which I am going to teach you. Okay, you need to work, guys. Without action, there is no result, right? So if you want to master a tool, you need to work. You need to spend some time on it, which I'm going to guide you hands-on. So don't worry. So I'm here with you to learn, to teach you, to make you experienced in an expert in Docker and Kubernetes. Okay, guys, see you tomorrow. Ta-ta, bye-bye. Thank you so much for attending today's session. Tomorrow, we are going to learn a bit more deep into Docker and setting up of Docker and other things. Thank you. Bye-bye.